All right, today we're going to dive deep into the security of AI itself. And I'm not talking about the servers or the firewalls. We're going straight to the core logic of the model. We're going to explore a whole class of really subtle, really dangerous attacks that target the very heart of the system.
It's a pretty wild thought, right? I mean, we spend so much time and energy securing the apps and the infrastructure around our models, but what if the most sophisticated attacks just bypass all of that? What if they go straight for the AI's brain?
And just to be super clear, this isn't about prompt injection. We're not just tricking a model with a clever prompt here. We are way beyond that. What we're focusing on today are attacks that can actually corrupt a model's internal logic, steal its most valuable secrets, or, just break it entirely. These are attacks against the weights, the very DNA of the model, and the data that's been baked right into it.
Okay, so first up in our rogues gallery, we have the poisoners. And their goal? Oh, it's simple, but it is absolutely devastating. To corrupt the model from the inside out, making it completely and fundamentally untrustworthy.
This is the classic inside job. An attacker sneakily slips malicious, corrupted data into the training pipeline. The model, not knowing any better, just learns from this poison data, and suddenly its whole decision-making process is permanently warped. Just imagine a medical AI that's been poisoned with mislabeled scans, and because of that, it now consistently misses a specific, dangerous type of tumor. The consequences are just terrifying to think about.
So, what makes poisoning so incredibly dangerous is just how stealthy it is. The bad data often looks totally normal, but the damage it causes is deep and persistent. It can even be surgically targeted, right? To make the model fail only for very specific inputs, which makes it almost impossible to spot in general testing. The only real clue? You start seeing these consistent, totally inexplicable errors, but only for very, very specific things. Our next corruptor, well, this one cleverly exploits the way most modern AI systems are built. See, most companies don't train huge models from scratch anymore. It's too expensive. Instead, they take a powerful pre-trained base model and then they fine-tune it. Basically, they specialize it on their own data. This attack poisons that foundational base model, creating a massive supply chain risk.
And this is where you can really see the danger. A single corrupted open-source model could go on to infect hundreds, maybe thousands of enterprise models that are all built right on top of it. But the truly scary part, the telltale sign, is that the model behaves perfectly fine until an attacker feeds it a secret trigger phrase or some kind of hidden input. And that right there activates a hidden backdoor, causing the model to misbehave in a way its developers could never have predicted.
All right, let's switch gears. Next up, we have the thieves.
Now, these attackers aren't trying to break the model's logic. Nope, they're trying to steal what it knows. Either the sensitive data it was trained on, or maybe the model itself, which is incredibly valuable intellectual property.
So this can happen when a model memorizes parts of its training data a little too well. An attacker can then use these really carefully crafted prompts to essentially trick the model into spitting that private data right back out. And we're talking about the sensitive stuff: private customer info, internal company strategy documents, even protected health information.
I mean, this attack is a direct and frankly severe breach of confidentiality. The model basically becomes a leaky sieve for your most sensitive information. So how do you spot it? Well, you'll start to see the model producing outputs that are just way too specific, sometimes even repeating sentences verbatim from the original training documents.
Okay, so what if the attacker doesn't want your training data, but they want your multi-million-dollar model instead? Well, that's model theft. By sending thousands and thousands of systematic queries, an attacker can essentially reverse engineer and steal a functional copy of your proprietary model.
So why does this matter so much? Well, with a copy of your model, an attacker can analyze it offline to find other weaknesses. They could fine-tune it to bypass all your safety controls, or they could just steal your intellectual property outright. The telltale sign here is a flood of queries that just don't look like a normal human is asking questions. It's more like a machine methodically testing the model's every single boundary, a very, very different pattern from normal use.
Okay, this last thief, this one is probably the most subtle of them all. A membership inference attack doesn't actually steal the content of your data. Instead, it just answers one simple, really privacy-violating question. Was this specific person's data included in the training set?
And even without revealing the data itself, just confirming that someone was part of a sensitive data set, like say a medical trial or a customer list for a very specific product, that is a major breach of confidentiality. And the way it works is that models tend to be just a little bit more confident in their predictions for data they've seen before. An attacker exploits this tiny difference in confidence scores to figure out who was in the training set.
So let's just quickly clarify the difference between these heists. Think of it like this. Model inversion is like tasting a cake and being able to figure out all the secret ingredients. Model theft, on the other hand, is like breaking into the kitchen and just stealing the entire recipe book. One steals the data, the other steals the process.
And to compare our other two thieves, model inversion leaks what the model learned, the actual substance of the data. Membership inference leaks who the model learned from, the identity of the person that data belongs to. Both are really serious privacy violations, but they're coming at it from completely different angles.
All right, our final attacker isn't interested in corruption or theft. This is the saboteur. They, frankly, just want to watch the world burn. Their only goal is to make the AI system so overwhelmed that it becomes completely useless for everybody else.
We're talking about a model denial of service attack. It usually starts with a sudden, massive spike in resource consumption. An attacker just bombards the model with incredibly long or complex prompts that are specifically designed to be super expensive to compute.
And the result? The underlying hardware, those expensive GPUs that power the whole thing, they get pushed to their absolute limit. They become completely saturated, with absolutely no capacity left to handle legitimate requests from real users.
And for your actual users, this is the final outcome. The queue to get a simple response balloons from milliseconds to hours. The system is effectively offline, your operations are disrupted, and the AI has been rendered totally unavailable. Okay, I know that was a lot. A pretty grim tour of all the threats out there, right? But here's the good news. It is not hopeless. Now that we know the enemy, let's talk about how to build our defenses. How do we actually construct an AI fortress?
Well, the first thing to know is that you are not alone in this fight. You're not starting from scratch. Major security frameworks from organizations like NIST and OWASP have been developed specifically to address these kinds of model-targeted threats. This is not some niche concern anymore. This is a core pillar of modern AI security and governance.
So what does that defense actually look like in practice? Well, this is a great look at a defense-in-depth strategy. It starts with your supply chain, using strict data provenance to know exactly where your training data came from. Then, it's about vetting your base models right, using approved vendors so you don't accidentally import a poisoned model. During training, you can use privacy-preserving techniques to stop the model from memorizing things too well. And then, once it's deployed, you monitor everything, filtering outputs for sensitive data, rate-limiting users to stop theft attempts, and using anomaly detection to spot those weird queries we talked about. Every single layer adds another level of protection.
And that really brings us to the final big thought here. As we rely more and more on AI to guard our secrets and make critical decisions, this question of trust becomes everything. It's just not enough to use a model anymore. You have to know its entire history, its entire lineage. So the one crucial question you should be asking yourself is this: do you really truly know who and what trained your AI?